Okay, we're going to talk about a couple of examples of projectile motion that shows up in sports. And one of them is the one I introduced in class the other day, is the rule that punters in football are commonly given, that they have to send the ball, keep the ball in the air 4 seconds and send it downfield 40 yards. Now if you think about it a minute, that means that they actually have to, the ball has to go downfield about 50 yards because the punter stands about 10 yards back behind the line of scrimmage. Okay, so the ball, if we draw it, actually has to go 150 feet downfield. It goes up in a parabolic arc, and the question is, how does the punter have to kick that ball so that it goes 50 yards total in 4 seconds? Now, why do you want it to take 4 seconds in the air? That's because that's about how long it takes for your own tacklers to get downfield to tackle the punt receiver, the punt returner. You want the tackler to hit the punt returner at the same time the ball does. So if the ball gets down there too quickly, the returner has caught the ball and is already running before the tackler's reaching. Okay, so we can solve this using our projectile motion equations. And like every other problem, we're going to divide it into 2 parts, the horizontal motion and the vertical motion, and then solve it to find out what kind of velocity and angle we have to go at. So the question is, how high an angle, and what is the velocity? All right. So the first thing you do on something like this is you resolve the velocity into 2 parts. Vx0 is going to be equal to V0 times the cosine of the angle theta, and Vy0 is going to be equal to V0 times the sine of theta. All right. Now remember that the horizontal motion determines how far the ball will go downfield, but the vertical motion is going to determine how long it's going to be in the air. All right, so for the horizontal motion, 150 feet, let me write down the equation first. The distance that's traveled is going to be equal to V0x times the time that it's in the air, the hang time of the punt. Okay, so that's going to be equal to V0 cosine of theta times the time in the air. And so we can write the time in the air as a function of the distance. T air is equal to x over V0 cosine of theta. Okay? All right, so that's let's see what we have here. We have that we know that the, excuse me, I should have written this a little bit differently. We know the distance we have to travel. We know the amount of time we need to be in the air, so we can solve this for V0 cosine theta. This says that V0 cosine theta is equal to x over the time in the air. So we want it to go 150 feet over 4 seconds. And so we want that to be 37.5 feet per second. That's the initial horizontal velocity. All right, so we got that. So we know what V0 cosine theta is. We need to figure out what the vertical component is. Well, let's see. We've got the vertical component Vy0 going up that direction. And we know that by symmetry, that if it goes up with a certain vertical component here, when it reaches the ground again, its vertical velocity is just going to be equal to minus Vy0. Okay? So we can use that to figure out what Vy0 is. Let's see, if I can erase, I'm going to erase this part. Okay. I know that V y final is equal to Vy0 plus AT. I know that Vy final is equal to minus Vy0 by the symmetry of this motion. And so that says to me that, let's see, minus 2 Vy0 is equal to AT. And so Vy0 is equal to minus 2 AT, minus AT over 2. And so this is equal to minus 32 feet per second squared. And the ball has to be in the air 4 seconds, divided by 2. And so that says to me that Vy0 should be 64 feet per second. All right, so by using this equation for the change in the velocity, I've determined what the vertical component of the velocity is. And we just said that the horizontal component was 37.5 feet per second. And so all I have to do is put those two together. I've got this value. And then I want to find V0. Well, V0, the magnitude of V0 is going to be equal to the square root of Vx0 squared plus Vy0 squared to the 1/2. That should be equal to the 37.5 feet per second squared plus 64 feet per second squared to the 1/2. And that gives us that V0 is 74 feet per second. That turns out to be about 50 miles an hour. And that's about right. That's how fast the ball comes off the foot of a punter, about 50 miles an hour. So you can realize why a punt blocker can get hurt trying to block those punts, trying to get in front of a 50-mile-an-hour football. And then we need the angle theta. Well, we know that the tangent of theta is equal to Vy over Vx. And when you put in the numbers for 64 feet per second for Vy and 37.5 feet per second for Vx0, you should get that the angle is equal to 59.6 degrees. And that kind of makes sense. When you see a punter punt in a football game, the ball comes up at a fairly high angle. And that's what they're trying to do, to keep the ball in the air for 40 seconds and make it go downfield 40 yards.